On this next unit, we're talking about graphing. So we're going to look at equations of a line. So this first one is kind of a cheat sheet. It shows you that when you have the origin, remember the origin is 0.00, when y equals m times x, it can either go diagonal going up from left to right, or it can go down from left to right. Then the equation of a line that intersects the y-axis is y equals mx plus b. So you'll notice the difference between the top section and the next section is that in the first section, it crosses at 0, 0 both times. So you don't have a number that it's being added or subtracted from. But on the next section, it does go through the y-axis at a different point. So that's why there's a b as part of the equation. And then the equation of a straight line parallel to the x-axis and passing through the point is y equals whatever that point is. So if this was point D, and let's say D was positive 3, then y would equal 3. And if D was negative 3, then y would equal negative 3. And then finally, vertical lines. You'll notice that for these ones, where it goes through is actually the x-axis instead of the y-axis. So that's why the equation says x equals that number. So for this one, x could equal positive 4, let's say that went through the 4. And for this one, x would equal negative 2 if that went through negative 2. So, if you leave home and walk in a given direction at a steady pace, your distance, d feet from home, is directly proportional to the time, or x minutes, that you walk. You can use a table and a graph to represent this proportional relationship. So, at 1 minute, you've gotten to 150 feet, and at 2 minutes, you've gotten 500 feet. So you'll notice that it went from 250 to 500 by adding 250. So we're going to add 250 each time. So at 3 minutes, you are at 750 feet. At 4 minutes, you are at 1,000 feet. And at 5 minutes, you are at 1,250 feet. So the constant of proportionality. So the constant is for how many feet does it go per minute? Well, for this one, it goes 250 feet per 1 minute. So let's graph this information on the chart. This is really hard to do because you'll see that it's really easy to go over by 1 in the x's, but to go up, you really just need to go up by 250. So the first one is 250, then 500, 750, 1,000, 1,250, 1,500, and 1,750, and so on. So at 1 minute, you go 250, and so on, and it makes a proportional graph where if you were to connect those dots, it would make a straight line. So I'm going to put that graph back on there. You should already have the graph and make it have a straight line because it went up by, 250 each time, and so on, and it went over by 1. So using the rise over run, find the slope of the line, well, it goes up 250 for every 1 minute. So 250 feet by 1 minute. Think of examples in which you would require rates of change. Well, miles per hour. You could do miles per gallon. You could talk about in terms of how much pizza that you should order. So how many pieces per person, and so on. So if you come up with extras, go ahead and write them down there. So the graphs give information about a penguin's number of heartbeats, b, over time, t, minutes, during normal resting and just before diving. When is the penguin's heart rate greater, during normal resting or just before diving? So it might be interesting to look at, okay, which one has a steeper rate, but what you really have to pay attention to are these numbers on the y-axis. You'll notice on the left-hand one, but they go up by 50s, but on the right-hand one, they go up by 100. So from point 0 up to the next point, you go up 150, you go over 2. So 150 over 2 is the same thing as 75 over 1. So that's 75 beats per 1 minute. And then if we look at the next one, it goes up 400 over 2. So up 400 over 2 is the same thing as 200 over 1. So 200 beats per minute. The one that is greater is obviously going to be your heart rate before diving. And the graphs give information about the distance, d miles traveled over time, t hours by cars and trucks on the California highway. So which speed is lower? You're going to do the same thing as we did before. How much does it rise over how much does it run? Well, it goes up 100 over 1.5 hours. So 100 over 1.5, but I want to know over 1, what does that become? The quick way to do that is to actually divide 100 by 1.5, and you actually end up with 67-ish, so right around 67 miles per hour. On the next one, you go up 100 over 2. So you're still traveling 100 miles, but this time it takes you 2 hours. So that's going to be 50 miles per hour. The one that is lower is actually the speed for trucks, which it should be.